Buon pomeriggio a tutti e benvenuti alla presentazione di chiusura di WebValley 2020, edizione Reimagined. Io sono Claudia Dolci e sono qui con Giuseppe Jurman e siamo i direttori della scuola WebValley. Per l'emergenza Covid-19 quest'anno abbiamo proposto una rimodulazione del programma, quindi non abbiamo 3 settimane di lavoro con i ragazzi, ma l'abbiamo ridotte a 2 e abbiamo collegato i partecipanti da remoto. L'Istituto Artigianelli ci ha supportato per quello che riguarda la parte metodologica del progetto e ci ha ospitati in quello che vedete alle mie spalle essere il head office di noi tutor, che abbiamo lavorato qui per 2 settimane coordinando il lavoro dei ragazzi. WebValley dal 2011 è in lingua inglese, anche quest'anno non abbiamo rinunciato agli studenti internazionali e ai tutor internazionali e chiedo anche un po' di pazienza seppur da lontano, ma per noi, per questa edizione abbiamo sperimentato tante cose e stiamo sperimentando anche qualcosa di diverso oggi, quindi abbiamo il primo evento streaming, quindi proprio alla 20ª edizione della scuola. E quindi insomma io chiedo, chiaramente abbiamo un supporto anche nascosto alle spalle e in bocca al lupo ai ragazzi che presenteranno. E passo la parola adesso a Giuseppe Jurman, direttore della scuola insieme a me. Grazie.
Welcome everybody to our international audience. We are here in the Istituto Artigianelli, who is hosting us for our head office for this fully virtual edition of WebValley 2020 we call Reimagined, because as you may know, the health situation worldwide has forced us to change our format. And now our students will be more than ready and more than happy to present you all the hard work they have done in these 2 weeks. So now we quit our introduction and we'll let the stage to our students, please.
So what is WebValley 2020?
Okay, we are preparing our students and we are getting ready to start.
WebValley is the FBK summer school for dissemination of interdisciplinary research. Since 2001, WebValley participants attend a first week of introductory courses in data science, visualization, artificial intelligence, and software for the specific domain of the project. For example, biomedicine, digital agriculture, and so on. Then the team chooses and uses the acquired tools in order to define and develop the research project together with scientists, technologists, and experts. Girls and boys learn how to organize their work plan to respond with innovative solutions to scientific challenges with strong ethical impact. At the end of the program, a working prototype of the solution as well as the project results are presented. As in a real research and development environment, the activities are developed both in team and in smaller groups formed on the basis of the students' personal interests and the specific tasks required to tackle the challenges. Each participant can contribute to the project with their own idea, skills, knowledge, and so on. Also, leisure time activities with informal gatherings are organized to let participants and tutors get to know each other, get inspired, and build a relationship among colleagues. WebValley 2020 is the newly conceived edition of the traditional formula. This year, the courses were carried out online through distance learning. All meeting, lectures, workshops, and discussion among team members were conducted in streaming using Microsoft Teams, with the support of multimedia teaching materials, together with experts and researchers.
This year, WebValley's mission is aimed to provide students with the operational and organizational tools necessary to approach data science for computational biology. In particular, we dealt both with the emerging omics biotechnologies and with computational tools, such as machine learning for AI solution in health. We were supported and guided by tutors specialized in several different disciplines and fields. There were those who dealt more with the biological and technological side, and others with humanities communication, organization, and work methodology. Despite the COVID-19 pandemic, by using collaboration tools such as Microsoft Teams or Azure, we were able to work as a proper research team.
The 20th WebValley edition hosted 21 students between 17 and 20 years old, 7 females and 14 males, from different high schools and different countries. 17 of these come from Italy and 4 from the USA. 2 Italian students were in charge of the communication office. They managed WebValley social media accounts and all the aspects of the project related to the graphics, including this presentation. WebValley is mainly, but not exclusively, addressed to high school, focusing on science and technology. The application for WebValley is open for students from all over the world who are willing to feed their interest in data science and for this year's project in computational biology. Let us also introduce Mario and Emma, 2 mascots who kept us company in our daily Scrum meetings. They represent the students who participate to WebValley, who already have the required basic knowledge. For example, hard skills such as technical competencies in biology, math, coding, etc. But also the soft skill to carry on a research project as a team, such as problem solving and open-mindedness. This 2 weeks journey was structured as follows.
During the first week, the whole team attended introductory courses in data science, visualization, and artificial intelligence software, with an emphasis on the specific domain of the project. We also started scheduled Scrum meetings, both as recap and as team building sessions. On the very first day, the WebValley program was presented, and then we and the tutors introduced ourselves. We also attended a first lecture concerning scientific communication with a focus on theater as tool for science outreach. The day after, we started several lessons to gain knowledge about the programming language and Python and R, which are the most used in data science, machine learning, which can be either supervised or unsupervised, and the importance of single cell sequences in tracking the state of a cell, and a dimensionality reduction, especially with UMAP algorithm.
In the second week, the work was mainly aimed at carrying out the project and preparing this presentation. We had some more lessons concerning how to visualize data, and we had several groups work sessions on different tasks, presenting a scientific paper, visualizing 1 out of 4 datasets, dividing the team in smaller groups working on the different parts of the project, and preparing the presentation you're watching right now. On Saturday, the 29th, we will discuss some videos we are producing as a communication products for scientific dissemination. With these videos, we are exploring scientific topics related to WebValley 2020 that we are particularly interested in, targeting a non-specialist audience and thus using creative languages such as cartoons and drawings.
This year, we didn't have one single aim to pursue, but a double one. And now we will focus on the first one, the proper scientific challenge in bioinformatics, and in particular, on single-cell RNA sequencing. We can start by saying that bioinformatics is one of the fields where the data science is employed. But what is data science? It's a part of the science that studies a huge amount of data using computer technology, algorithms, machine learning, or deep learning, to obtain information. Consequently, bioinformatics studies and analyzes biological data using informatics to improve our knowledge of biology. This knowledge, it turns, can be used to, for example, in medicine. Obviously, single-cell RNA sequencing is only a part of one of many branches of computational biology. Other branches are, as you can see in the image, computational anatomy or computational neuroscience, or others that you can see. Single-cell RNA sequencing is used for genome sequencing, and it starts by isolating a single cell from the tissues you want to examine, and then put them into machines which are able to translate the RNA into a digital language. So at the end of this process, we will have a matrix with a column for each cell we have examined, a row for each gene present in the cell, and in the matrix cells, the number of the specific gene in the specific cell. So now we have the data, but it's not perfect. And this data cannot be used yet, because unfortunately, our technique is not yet 100% accurate. For this reason, we have to use algorithms like normalization to delete some errors, and only after that we can start to read our data. But how we can read our data? We need to use again data science tools, such as UMAP for the dimensionality reduction, together with clustering tool. After making use of these tools, with a simple plot, it's possible to see different group of cells, which have different characteristics that can give us very useful information about the health of the cells.
So that was a short introduction on what single-cell sequencing was, but single-cell sequencing presents a wide variety of applications, including biological applications or ways to understand our cells and tissues at a deeper level, as well as translational applications in precision medicine. There are three primary ways to apply single-cell sequencing to understand our cells. First, single-cell sequencing allows us to identify specific subclusters in cell types and tissue types to help us understand what specific cell types could be contributing to a disease. Second, single-cell sequencing maps the progression of cellular processes, such as cellular differentiation. This allows us to see the specific genes and molecules involved with stages of these processes. Lastly, this sequencing allows us to examine differentially expressed genes, looking at what genes are activated in disease versus healthy cells. Taken together, we can use this information to better understand diseases such as cancer and how they work at a cellular level.
In addition to the biological application of single-cell sequencing, we can further translate this into precision medicine. Inference of drug resistance, improved early diagnosis, and development of effective treatments are three ways that single-cell sequencing can be used as a tool for translational medicine. Single-cell sequencing allows us to better track cell morphology of a disease, such as cancer, as it progresses throughout the body. Through this, scientists are able to identify key genes that may result in drug resistance within a tumor population. By identifying these genes, scientists can diagnose diseases early on and give patients a better quality of life in the future. Identifying these genes also helps scientists to develop treatments that target and work specifically to prevent further progression of a disease. Another relevant aspect of single-cell sequencing in data science are ethical issues within the field. Oftentimes, the falsification of data can create investments into medicine that is not truly effective. We want to keep this in mind when developing our project. This is why we wanted to ensure our techniques were easy to follow and used real-world data in the process. This transparency is something we were careful to keep in mind for the final project and development of our dataset.
Computational biology has seen exponential growth in recent years, mainly because scientists have never had such a large amount of data at their disposal. But such huge amount of data needs to be collected, stored, managed, and analyzed in order to become meaningful and thus useful. As you should have guessed, developing the skills required to become a professional data scientist is very difficult. Here she is, our data scientist. A data scientist operates in a continuously changing environment. and needs tools and skills to face very many challenges. Let's now see what makes a good data scientist. Here is briefly what we are talking about. First, hard skills. A junior data scientist must know mathematics and statistics. Both of them are necessary for working on the following topics. They are the foundation upon which most of their technical skills lay. He must also know programming and more specifically machine learning. These tools are used to extract meaningful information from raw data. For example, in our training path we use Python and R. And for what concerns machine learning, we use cutting-edge dimensionality reduction techniques such as principal component analysis, t-SNE, and UMAP. Then, after processing the data according to specific necessities, the main task of a data scientist is to present the information he discovered in an effective and meaningful way. After all, his work can influence very important decisions. The visual representation he produces must be truthful while conveying meaning. And why not? Also be pretty to look at. Last in our list, he must know the context in which he is operating. Studying computational biology allows him to know where the data he's working on comes from, how it's being collected, and what it represents. Together with the hard skills, here we can see what the soft skills of our data scientist should be. Working with what we call big data also means working with many people in teamwork. Otherwise, big issues can arise by having problems collaborating. At this point, you will know better than me that working with a multitude of people can be difficult and the timetable can change in any moment. So organization is a vital skill for a scientist, as important as being flexible. The multidisciplinarity present in this working environment can often put you and your team in particular situations that need to be faced from different points of view. The last but not the least soft skill we need is what we call problem solving. As just said before, you may be working in non-ordinary situations, for example with strange datasets or libraries that are not working as you might expect. Distinguishing the various aspects of a problem is very important for its identification, definition, and resolution. Here we can find a handful of tools that we use in our training path. Some of them are useful for collaborating with peers like Git, the most famous world-renowned versioning system, or to work in cloud, like Microsoft Azure. Others nowadays are fundamental to work with machine learning, such as scikit-learn, TensorFlow, and PyTorch. And some of them, like Surat and ScamPy, serve as great tools for analyzing datasets of single sequence cells. They are almost all free and open source, and for any of them you can find plenty of tutorials on the web to get started with. But that's the point. It's hard to manage all this information and learn from it, especially if you're a beginner. Becoming a data scientist is then a real challenge. And our challenge?
Our challenge is precisely to help young students becoming a data scientist, guiding them step by step and giving them everything they need. So we're designing a training course for junior data scientists in computational biology. In many trainings, often tutors and teachers focus solely and exclusively on their final result, neglecting and ignoring what are the right skills that have to be imparted to students. But by enrolling in our training path, students will achieve all the necessary skills in the best way possible. But why do we believe that it will work? Because it is conceived and designed by students for other students, because it gives everyone a chance to deepen the subject of computational biology like never before. Every learning module, timetable, and methodology were made considering students' needs, desire, and prospects. At the same time, we tried to give life to a new wave of teaching, making the social distancing due to the COVID-19 emergency not a lack, as there could be no contact, but one of our strengths. Also, in order to facilitate learning, since there could be no physical contact, which is very important in learning for both us students and for the teachers, we found ourselves using innovative tools like Microsoft Teams and other online help tools like Miro, Visual Studio Code, and Trello that allowed us to work all together on the same project at the same time, to plan teamwork and even organize leisure activities with all the group of students, also with people very far away from us. Since this course is structured and designed at 360 degrees, undertaking it will bring benefit not only to students, but also to many other stakeholders. In general, every school, university, or specialization school that makes it possible to follow our course will provide valuable resources for the next generation of researchers. It is valuable for a multitude of reasons, in particular because it involves a lot of subjects, takes nothing for granted, and makes it easy for educational institutions to find all the right resources in only one big course. Moreover, any institution that provides education and training will raise the educational level of its students, as the course covers functional, cutting-edge concepts. The exercise and workshop that we will carry out will help young students to gain meaningful experience and will allow them to understand and become interested in a completely new world. The course aims at being as engaging as possible, not only for students, but also for all those teachers who teach subjects related to the world of technology. We find themselves touching new and current topics. But not only schools can benefit from the WebValley training path. Our training package will also bring valuable human resources to research institutes. It will educate young, creative minds ready to face any new challenge in the best way possible. Innovation hubs like IP4FVG in Area Science Park in Trieste are another important stakeholder to us, as they are always striving for innovation, living in a reality with many possibilities, both from the point of view of the research and of the work. In this way, a student who has just completed this training path can have the widest range of possibilities at his disposal. Lastly, companies that have to deal with a huge amount of data will benefit from this course by having the chance to employ junior data scientists already prepared to take real-world problems as soon as they complete this training path.
After this introduction, we can finally explore the structure of our course through three main steps. First, the pre-training, where the attendants have the chance to acquire the necessary skills to gain the pre-requirements of the course. Second, the proper training, composed by theoretical modules and their applications to use cases, thus on authentic datasets. And third, a post-training concerning feedback and evaluation. As for the pre-requirements, conversely to what you may think, attending a technical or scientific high school is not mandatory. In fact, students from all kinds of different schools and study fields are welcome, including humanities, communication, and graphic design, and so on. This multidisciplinarity is also one of the main traits of the teachers, all with their different roles and academic backgrounds. The most important pre-requirement is a shared passion for the subjects that are the core of the training package, particularly biology and computer science, since the students will have to deal with them for the whole course.
However, in the months preceding the course, all the participants need to acquire fundamental skills and knowledge to fully understand the topics of the actual training. Thus, we identified the areas the students need to feel comfortable with, and we gathered reliable resources and methodologies for them to start learning. The first selected topic is coding. Here are a few tutorials, examples of tutorials. Secondly, the participants should get acquainted with several collaborative tools and development environments. Aside from coding, students should have some theoretical knowledge in maths and in biology, possibly integrated with some DNA-related experiments. English proficiency is also a must, along with essential organizational soft skills needed for alone and teamwork.
The course will be split into modules, where each module will teach a specific topic from the ground up. Along with more technical modules about machine learning and single-cell RNA sequencing, the course will provide participants with the chance to improve their soft skills. Machine learning has grown rapidly over the last few years, and there is a great demand for qualified developers in that field. The main classification of machine learning is based on the type of data used to train a model. The most used type of machine learning for single-cell sequencing analysis is supervised learning, which is able to learn the structure of data from raw and preprocessed data without any manual labeling. Supervised learning, instead, learns from labeled data, that is, data whose structure is known. Another type of machine learning used in other study areas is reinforcement learning, which is based on a reward-penalty system. The course will not delve too much into supervised machine learning, since its use is not so frequent in a single-cell sequencing study environment. But the most important algorithms are explained. The common workflow of supervised machine learning algorithms is what you can see on this slide. So, training data is fed to the algorithm along with the labels connected to them, and the model is built using this data, and is then kept in a static way. So whenever a new type of data that has just been collected needs to be, for example, classified or requested, it just is passed through the model, and the model is able to predict the labels. The two tasks achieved by supervised machine learning are regression, providing a continuous output, for example, determining the road direction from the image of a road, and classification, which provides a discrete output, for example, classifying the type of a flower. Starting from the simplest kind of supervised machine learning, k-nearest, which works by comparing the input sample to all of the dataset entries to determine to which one it is most similar to, the course will then concern neural networks and deep learning, while also talking about validation methods and parameters tuning along the way.
The technical modules will mostly focus on unsupervised machine learning, thanks to the many applications in the single-cell sequencing field. The common workflow of unsupervised machine learning algorithms consists of data being passed through an algorithm to look for patterns and form clusters. When new data is introduced, it is passed through the model created to be assigned to a cluster or given better representation. Here you can see the three main types of unsupervised machine learning. Feature extraction is about removing useless features or dimensions from the dataset after analysis. Dimensionality reduction is like feature extraction, but is completely autonomous and also transforms the data. The algorithms that will be explained in depth to students will be principal component analysis, or PCA, T-distributed stochastic neighbor embedding, or TSNE, and most importantly, uniform manifold approximation and projection, or UMAP. Lastly, clustering is about grouping together the similar samples, which leads to unsupervised classification and labeling. The main algorithms to achieve clustering are k-means, hierarchical clustering, HDB scan, and phenograph. This is the scikit-learn machine learning algorithms cheat sheet. And at the end of the course, students would be able to correctly interpret it and use most of the listed tools. Unsupervised learning is especially useful in a single-cell sequencing environment, since it allows collecting useful information about cells and gene expressions. Thanks to dimensionality reduction and clustering techniques, cells can be assigned a type, and the behavior of different cell groups can be differentiated due to a differentially expressed gene. The evolution of cells and their gene expressions through time can be visualized, providing a good starting point to study topics such as how an embryo's cell develop.
I would like to provide a little more insight into dimensionality reduction just due to how vital it is in a single-cell sequencing experiment. These techniques with dimensionality reduction are especially useful for those large data sets which have thousands of genes to track, which students will be working with throughout the course. The small tutorial I created here shows a few of these different strategies and focuses on visualization of these dimensionality reduction techniques. The small snippet I have here takes a specific focus on uniform approximation, manifold approximation and projection, or UMAP, as well, and later on explains why it is especially favored over other techniques. This theoretical background in general is very necessary before exploring the data sets and procedures. Here I've used the R programming language for my tutorial, though Python will be displayed in the application to the dataset. Both of these languages are capable of the techniques, as mentioned before, but I felt it was important to share a different view, which is what the students will learn as well. So I'd like to speak a little bit to the methodology of our training course and some of the aspects that allow students to learn to the best of their ability. After all of us read literature and didactic teaching techniques, we included certain features that we know will prove to be effective. Here are some of them. So first, we would like to have guest lecturers that are experts in the field. Throughout WebValley, for us personally, we have learned that the bulk of our single-cell RNA sequencing material by listening to experts in the field. We would like to include this feature in the training course in the form of videos to watch from guest lecturers. They will walk through tutorials with a Jupyter notebook or present overall slides about the material. We'd also like to have hands-on notebooks for the students to try out the concepts for themselves, because if there's one thing that I've learned about single-cell RNA sequencing, it's that the concepts cannot be simply learned by watching a teacher or someone else run the code in front of you. You must construct your own code for each step along the way of the experiment and understand exactly what it is you're doing. We plan to have notebooks also with conditional cells, meaning the student must create their own individual scripts from scratch and have it run with a certain output in order for it to pass that certain cell and move on to the next step. This is ultimately the most effective way to prepare them for the project-based learning, or the real-life data sets to experiment on. Sorry, I was not quite finished with that slide, but we will provide public data sets and walk the student through the experimental procedure step by step. This will be a mix of provided code with commentary and parts that the student must attempt themselves. Once they feel confident about working through these data sets, they will attempt the final project, which will be to extract a public single-cell RNA sequencing data set and work through the entire process from start to finish. This includes reading in and normalizing the data all the way to UMAP visualizations. Then one of the most important aspects of being a successful researcher is scientific communication, or learning how to express what you have learned to the public. The final presentation will be on the data set you choose to explore, and you must present relevant background, procedures, and applications. Working in a team will allow the students to stay motivated with these team revision and practice sessions and contribute and be up to date on the material of the course up to that point. The practice sessions will allow them to apply their knowledge as well. And finally, providing snippets of code to complete, edit, and fix, and scheduling free time, social activities, and these other aspects displayed on the slide have been proven to be great ways to learn to be a better programmer, better at scientific communication, and be able to present your project in general. There should never be a barrier in education, which is why the materials of the lectures will be free and easily accessible within a compact working environment. Here we have an example of a notebook tutorial specifically on supervised learning, a subset of machine learning. Some features I would like to bring to your attention are first, the markdown text in which we explain concepts in detail in combination with code and detailed descriptions of what each command does. A WebValley student has carefully described the k-nearest neighbors algorithm in this specific notebook while providing an example with expected output.
Just as important as technical skills, soft skills are necessary to be a great researcher, since they enable people to navigate their environment, work efficiently with others, perform well, and achieve their goals. Some of them will be acquired through group activities, both pertinent to the topic of the project, such as analyzing data together, and non-pertinent, for example, team sports and other team-building activities, while others will be dealt with in specific lectures, paying particular attention to the relationship between ethics and science, an actual topic whose comprehension is crucial to a data scientist and to any scientist in general.
A key part of the project is it's the actual training. In this section, we will explore the hands-on experience of the course. The training provides 4 different datasets as use cases to perform authentic data analysis. The first one contains gene expression values for nearly 6,000 cells from patients with oral cavity tumor, so cells from the neck and the head of the patient. The second dataset is the largest and contains data from more than 10,000 cells from mice with implanted tumors. The third one contains over 44,000 cells from 7 COVID-19 patients, both ventilated and not, and 6 healthy control patients. The last one we analyzed is the Zheng Data Set, which contains values from 3,300 cells from human patients, which present 4 different experimental conditions. Real-world dataset like this can be massive, and analyzing them in a reasonable amount of time requires a substantial amount of memory and CPU. In fact, we decided to perform all the computation using cloud computing infrastructure provided by Microsoft Azure. This service allows us to run heavy tasks on remote machines that are better suited for them. The task we are going to describe in the next slides were carried on 2 virtual machines optimized for analytical workloads with 144 gigabytes of RAM and 72 GPU cores. Data scientists need to learn the proper IT and computer science skill, like distributed computation paradigms, to deal with such huge amount of data.
Working on the HNSCC dataset, we went through these 5 steps to understand which cells are contained in the dataset. The dataset provides a table containing the gene expression values already normalized. The expression value of a gene is the measurement of its activity in that specific cell. On the rows, we have the cell names, which do not include information on the cell type. And on the columns, we have the gene names. In total, we have almost 6,000 cells and 24,000 genes. In addition, the dataset provides information on the cells that were deduced by the authors of the paper. Once the dataset was loaded, we applied the Dimensionality Reduction technique UMAP. The result is a table with the same number of rows, but only 2 columns. In this way, we can plot a set of 2-dimensional points representative of the original data. Then we identified the different clusters so as to group cells with similar characteristics. Each cluster was automatically identified by DBScan and is represented by a color on the plot on the right. At this point, we tried to identify the marker genes, that in other words are the most significant genes for the cells in that cluster. The result of this process is the series of plots you see. Each plot indicates which are the marker genes for one cluster. On the right, you see a magnified version of the plot from cluster 0, and highlighted in red, 2 highly expressed genes that we identified as marker genes for that cluster. Once we had the marker genes, we tried to infer the type of cells that populate each cluster. The cluster annotation was accomplished using the online database PanglaoDB. We analyzed deeper the characteristics of the cancer cells. As we said, the dataset provided some labels containing further information on the cells. We used the isCancer cell label to investigate which genes are correlated with being a cancer cell. Comparing the expression values of cancer and non-cancer cells, we found that the genes KRT17 and 14 are highly expressed in cancer cells and low expressed in other cells. As you can see in this slide, the correlation between those 2 genes and cancer tissues was then confirmed by Protein Atlas. Further development of this project could include trying different settings when performing dimensionality reduction, as well as analyzing in depth cluster 0.
In fact, cluster 0 is by far the largest and the most heterogeneous of all clusters.
The second dataset we analyzed is the mouse dataset, which provides gene expression levels for more than 10,000 cells, collected from 12 mice in which 6 types of syngeneic tumors were implanted. In order to analyze it, we followed 4 steps. First, we loaded the data, then reduced the dimensionality and performed clustering, and finally trained 2 classifiers to predict in which cluster each cell would be. Here, we see how the gene expressions label is structured. Each row represents a cell, and each column represents a gene. As we said before, the matrix is composed of 10,473 rows and 27,900 columns. First, we divided the dataset into a training set and a test set. Then, in order to plot the training set data in 2 dimensions, without losing important information, we performed dimensionality reduction with UMAP. In the resulting graph, each dot represents a cell. The algorithm managed to associate similar values to cells with similar gene expression levels, so we can see them in distinct groups on the graph. Now, we can proceed with clustering. On the UMAP projection, we apply the clustering algorithm dbScan that will group cells with similar gene expression levels in distinct clusters. On the graph, we see each cluster represented with a different color. Once each cell is assigned to a cluster, we can train a classifier model, in this case stochastic gradient descent, using the training set with the corresponding clustering results as labels, and test it with the test set. In the graph, the UMAP projection of the test set, where each dot is colored according to the classifier prediction. Unfortunately, in this dataset, we don't have any labels, so we have no way of measuring how well the classifier did. But from the graph, we can see it did a pretty good job in clustering cells. Here, we repeated the same process but with different classifier. This time we used random forest, which is a more complex model of classifier. And we can see that given the same training set, both managed to cluster the cell pretty accurately, but with slight differences. To further analyze the dataset, we could tweak the parameters for some algorithms, mainly random forest, in order to improve its performance. We could also inspect the differentially expressed genes in each cluster to identify different cell types.
This dataset stores the gene expression values for 26,000 genes from 45,000 cells from COVID-19 patients, specifically peripheral blood mononuclear cells. These cells are labeled with the condition of the patient they were extracted from. The conditions are healthy and coded. The goal is to train a classifier with the condition as the label to make it predict whether the cell is from a healthy patient or not. The dataset was distributed in a format that can be read as an annotated matrix, and the samples were ordered in such a way that the ill cells were on the top, so we had to make sure that we accounted for that before dividing them in a training and a test dataset. We handled that by using the stratified k-fold, which ensures the same distribution of labels in both datasets. Then we used the UMAP dimensionality reduction algorithm to plot the cells along with their labels. As you can see, with the default parameters, UMAP does a great job in dividing cells by type, but the ill cells are probably too similar to their healthy counterparts to separate them well enough to run a clustering algorithm. That's not our problem though. What matters to us is that the 2 plots here overlap, meaning that there aren't cells in the test set that would fall in the empty area of the training set. Our classification model won't be easily confused by our test set, or by any set of cells from the same tissues, probably. We first ran a random forest classifier, training it on the training set and making it predict the test set. The accuracy and the MCC here are high enough. The difference between healthy and COVID-ill cells is high enough that our decision trees can predict the origin condition and fairly confidently. But the surprise here lies in the SGD classifier. This classifier trains a linear model, in this case an SVM, with stochastic gradient descent, meaning that the training time is low, much lower than the random forests, but the results can be comparable, and sometimes better, like in our case. Both metrics are higher, but they're not the maximum, which is actually a good sign. It means that our model isn't overfitting. The low-dimension representation may be tailored to our needs if we pre-process the dataset accordingly, but that's not a real problem. We could instead try other classifiers and check whether there's a better one, not only in terms of accuracy, but in training time too.
Sparsim is an R tool for a simulation of a single-cell RNA sequence count table, developed by Giacomo Baruzzo from the Padua University. With this tool, you can simulate raw and normalized data from pre-existing datasets, like the Zheng Data Set. Here, I choose only the first two experimental conditions, the Urquhart and the T-cells. That means that in this dataset, there will be only data from these two cell types. The simulating function can create the gene expression intensity and variability, as well as the technical and biological variability. With the UMAP library, we can reduce the dimensionality of our dataset, transposing a 19,000 by 3,000 matrix on a 2-column matrix without losing any information about the data. Here, in these 3 scatter plots, you can notice that the simulated normalized dataset plot is very similar to the real data plot. This means that the clustering was very accurate. The clusters are already labeled because the Zheng dataset is already provided with labeled data. Another element very important to research in a single-cell sequencing dataset are the marker genes. Markers are genes that are differentially expressed between the two types of cells. To find the most differentially expressed genes, we run a p-test. The p-test is a statistical test which returns a value between 0 and 1. A p-value lower than 0.05 is statistically relevant. With the first 10 most relevant genes, we can frame a box plot and a scatter plot. In the box plot, we can see the difference of gene expression values. In the scatter plot, the more the gene is expressed, the more the color is intense. On the right side, you can see a differently expressed gene with a corresponding box plot and scatter plot. On the left side, you can see a box plot and a scatter plot of an equally expressed gene. Since there are more experimental conditions in the Zheng dataset, a further development of this code is to introduce new conditions in our dataset to see how the previous scatter plots will develop.
We've prepared a video tutorial that shows what you've done, and it goes more in depth in the code itself. And here's a short clip.
So we will group these cells in such a way that cells that are owned by the same group has similar characteristics. First of all, we create the variable db, calling dbScan fit on the transformed data. Inside the db.labels underscore, we have the labels, so the information about the clustering. We plot the same exact cells we plotted before, but now we use the labels as colors. As you can see from the legend on the right, we have 7 clusters from 0 to 6 and 1 negative cluster. The negative 1 cluster contains the outliers.
As we know, development is no good without refinement and feedback. So in addition to creating the actual training model, we wanted to make sure it was producing what it was intended to do. We did this with a few key aspects. First, we have the feedback form. So we created a feedback form that you can scan the QR code on the next slide to view. Please feel free to fill it out and give us feedback on how we presented and put together the training model.
Students that have completed the course can join an alumni network on social media to connect with current students and other alumni. Students can exchange opportunities, share thoughts, and talk about research being done that is relevant to what was covered in the course, but at a higher level. Students can ask for help from alumni, and alumni can continue to contribute to the course over time with their experience.
One of the important goals of this course is to prepare young data scientists for a career in computational biologists. This means that the students should have the opportunity to apply their data in industries and companies. One way to do that is to make internship opportunities available to alumni via a database with companies looking for young data scientists, so that our students can bridge between theory and application to see how their knowledge works in context.
Through the course, we have seen the application of different techniques to real-world data sets. As shown in the use cases part of our presentation, the students will have the chance to try their skills on real cancer tissue and COVID data sets. After you finish our training program, students can remember that there are a plethora of different data sets to find online for them to run their own analyses on. They can follow the modules that we provided for them and for any other data sets they may find. They can try to reproduce the PCA, the UMAP, or the TSNE, compare and verify the results with the real paper results, and stay connected with us who made the course. We can help you, and you can help us.
Okay, you know you have learned something only when you're able to teach it to others. If with the pre-training program we wanted to make our students passionate about this subject, with the post-training program, we want our students to continue the path they've undertaken with us. It could be very useful for the students to have alumni giving lessons or tutoring or simply lending a hand to new students during the training we have just described. This is undoubtedly a very effective method for alumni to stay in touch with other people with the same passion and interest in order to build up a strong community of young data scientists, as we expect this to be the near future of data science. It is also a very effective way to stay well trained on the subject, as you might have understood that is an always changing, dynamic environment.
Here is a Google form that is very similar to the feedback form that may be displayed at the end of our proposed course. If you would like to scan the code on the screen, we will provide some time to do that while I continue to talk. So students will have the opportunity to gauge how comfortable they felt with the material throughout the course and what they would have liked to cover more or less. This will be extremely useful in our trial stages of implementing this training course into Italian schools, as well as to make continuous improvements over time.
You just saw the complete structure of our training model, from pre-training on biological and mathematical knowledge to application of real-world data sets. Now, we would like to recap and explain why it will be successful in settings with students who aspire to be computational biologists and/or data scientists in other fields in the future, just like most of us. Let's go over a few specific points. First, we have the pre-course material. In this, we provide knowledge and all the necessary skills we felt were integral to feeling comfortable with before approaching data science, computational biology, and single-cell sequencing. Throughout the first week of WebValley, we were exposed to these firsthand, from math, biology, and working environments such as R, Python, and GitHub tools. From this, we designed our course to implement all of these so students would come into our course with a solid background with which we would optimize the effectiveness of their learning. Secondly, we have real-world dataset practice. The datasets we use within our training program are publicly released in manuscripts on NCBI. We walk through the entire process for 2 of these datasets while providing modules on each technique. This hands-on learning practice gives the students the closest possible experience to something they would experience in the real world. It also allows students to refer back to these modules when pursuing similar projects in the future. The third point is the verification by professionals with real results. Luca and Gabriel were so nice, and other experts helped us look through our dataset and verified our code. And finally, we have made by students for students. So our first week of WebValley focused on learning skills and figuring out things we needed to know, which helped us to develop our pre-training courses. This eventually helped us better understand what was needed as a student in order to learn. We carried this information over to the second week, where we were able to develop our targeted training plan. In addition to our prior background from the first week, we also used detailed boards of our customers, in this case the student, which provided a targeted approach that would fit needed skills. Because we were all able to personally go from pre-training, actual training, and post-training, we were able to develop a unique course that ourselves would also take as a young data scientist developing our skills in computational biology.
Now that all the features of our training program have been disseminated carefully, we would like to address our next steps for truly implementing this training course into schools. So first, a little bit about the scientific contents. For the tools and methodology, as mentioned throughout this presentation, we will work with Jupyter Notebook and other resources that allow the students to take quizzes and manually code in order to assure that they understand each step of a single-cell sequencing experiment. Though we feel confident in our skills to teach the information, rest assured, as professionals in the field will also approve all the modules of the course. For theoretical basics, every student must start with the basics in a complex research project, no matter what topic it is. Before diving right into coding, the modules covering the complicated techniques will be cited from papers and studies of professors and other qualified researchers. For coding, it's arguably the most important aspect of a single-cell RNA sequencing experiment. We plan to create modules for both Python and R so the student can gain a full knowledge of the techniques involved in the experimentation from start to finish. The coding modules will be a mix of displayed code with commented out input and spaces for the student to try it for themselves. And finally, for the biology, on a molecular level, the biology of single-cell RNA sequencing can get quite confusing, but the modules are created on the assumption that the student only has a baseline biology knowledge. By the end, we will strategically create the modules so that the student can learn from the ground up and be able to explain the biological implications of such things as dimensionality reduction. In terms of our stakeholders, we are happy that we were able to create a syllabus for this training course to be customized for different schools around Italy, as well as mapping the prerequisites that are necessary to become a successful in single-cell sequencing research. And finally, using it, applying your knowledge from the course to real data sets as presented in the use cases.
This training package and its model have greater implications on the development of education from a young age. The model can be implemented into heterogeneous landscape of high schools with additional courses that can be added later on to tailor the program to a specific concentration of a high school. This slow implementation and constant verification can help contribute to a successful integration of the training module within education programs throughout Italy. For example, within the theater workshop that we are attending at WebValley, we are producing our own videos of scientific dissemination, which could also be considered as teaching material prototypes, once again produced by students for students. Here is a sample material that we will discuss tomorrow with the expert Andrea Brunella.
With this video, we finish our presentation, thanks to all the students, and now we move to the question answer part. And for that, I have the pleasure to introduce you to Elisa Guardabasso and Rachele Villani, two tutors of our student that follow the student throughout these 2 weeks for methodological and strategical topics. Okay, so please, Rachele and Elisa.
Thank you. So, hi everyone, we're going to read some of the questions that were asked to the students. So first of all, I would like to say that there were a lot of greetings to the group of students and the work that they did. So you should be proud of your presentation and the work that you did in these 2 weeks. One of the questions comes directly from one of your teachers, and she's asking you to evaluate this program in the future and to consider if you think that this might be done in an online version and not just in-person version, based on your experience during the lockdown and during these 2 weeks. So we have 6 of our students that will ask the questions for us. Is there somebody of you that wants to speak? Okay, John.
Yeah, well, can you hear me?
Yeah, go ahead.
I think I had an online learning experience not only with WebValley, but also with my school too during the lockdown period here in Italy. I think students just need time to get used to this new type of learning because it's not that easy as it could seem. A lot of new online tools are being created every day to make this new type of learning experience more accessible. So everyone, I think, is just looking forward to get the best learning experience because we just need time, I think.
Thank you, Giovanni.
Yeah, I think this type of learning course could be adapted to any type of classroom format because it allows the students to, it allows for independent learning. It allows us to look at the explanations and do the modules by themselves. So it's a very independent process. And if there's a teacher around for students to answer questions, that's great. But we would also like to have an online community where students can also ask questions. So I think this learning module could be, this training course could be adapted to any type of learning environment.
Okay, thank you, John.
Thank you.
We have another question from another teachers that would like to know which part was most difficult for you, and also what can it be some kind of barriers to the implementation of the program in the future, or some strengths that you find in the program. So please, who would like to
answer? Clara. Yeah, first Clara, then Davide. So for me, some of the hardest stuff was the computational aspects, a lot of the UMAP, and just trying to understand it, but our tutors and guest speakers did a really amazing job just breaking it down and explaining it to us. I think one really unique strength about this specific program is the interdisciplinary aspect of it. Not only did we learn the very technical and biological aspect, but we also talked about the interdisciplinary and the application of our research. So we always made sure to go back to what the customer needs and wants for our training module and what to put into it.
Yes, I think that a barrier could be the fact that the students will not have the opportunity to talk directly with the experts. But I think that if the teachers will make an effort and try to understand themselves the aspects they are teaching, and if the students help each other, it will be easy for them to answer the questions they have. And since we students thought what were the problems and the questions we also had, I think many of the questions they will have are answered inside the notebooks, inside the slides, inside the video tutorials. So I think that's covered.
Thank you.
Yeah,
okay.
so...
Dale wanted to add something.
Yeah. Another thing that, at least speaking from my personal experience here in WebValley, is that I found maybe some programming classes easier than some other classes revolved around biology. So one important aspect is we talked about it before. Working in teamwork is really important because you don't have to perfectly know every aspect of it, of every topic, but working in team is very useful to develop the ability to work on a final project and to help really other people, because biology is that.
Thank you.
I think that also Giovanni might be wanted to say something, or we can go to the next question. So they wanted to know also in which topic you had difficulties. All the teachers are asking these funny questions about
difficulties.
Yes, about difficulties. But it's also important to realize that you did this program in just 2 weeks, and you were very good at it and challenging a lot of new experiences that you had to underdo, because yeah, it was also the first time also for us, for the tutors, to monitor your activities. So it was fun and challenging and demanding at the same time. So which was the most demanding moment?
Yeah, I would say first Carmen and then John.
So for me, the most complex topic to understand was the Dimensionality Reduction and the UMAP lectures, because on the second day of school of WebValley 2020, we just started with this complex topic without first building the grounds. But then in later and further lessons, we cleared every doubt that we had, and now we have strong knowledge of machine learning. At least this is how I felt it. This is how I conceived it.
Thank you, Carmen. John?
Yeah, so I come from a wet lab background. So one of the hardest things coming into going into a computational biology project is learning all the computer science and learning how, like UMAP, TISME, how all those tools work. But one of the things that was great about this program was I was really able to play to my strengths and make connections between biology and computer science. And I think that really helped me gain a grasp on the more difficult concepts.
Okay, now we have a question from the president of FPK, Francesco Profumo. He's greeting you as all the others, and we also thank him for being here and following the presentation. And he wants to know which are, in your opinion, the advantages of working online. There was something that you enjoyed more than you would have in person, or there are some aspects that you think are positive? So it's too easy always to talk about disadvantages. Let's try to look at both of the sides.
Clara volunteered first.
So I think something that was really useful was that all of our lectures were recorded. So we were able to go back. So if I didn't understand a topic, such as UMAP, I would go back and keep watching, and being able to work through it with the video was really helpful for me. And in addition to that, we were able to work well together and call each other out of the scheduled hours to further develop our knowledge as well.
Thank you, Clara.
Okay, we have another question from one of your lecturers,
Yeah.
I think. Or
Carmen wanted to add something.
Yeah, go, Carmen, go.
Yeah, I just wanted to say that I think that the WebValley 2020 project really sets an example for online classes, since it accurately took every teaching aspect into account, from the working environment, which was Microsoft Azure and Visual Studio Code, to the communication channels that we used, Microsoft Teams, and also the WhatsApp groups, and also the great organization work of our team of tutors, and the professionalism of the teachers who gave us online lectures.
Thank you.
Thank you very much, Carmen. Yeah.
Yes, we have now a comment from Viviana Sbardella, the Sovrintendente Scolastica, who is in charge of innovation projects. And she wants to greet you. I'm trying to translate. So she wants to greet you, and she says that your work is great, and it's evident the effort that you put in it, and that you're very serious and involved in the program, and that everybody's talking about knowledge and skills, and this is an important process. I think that she also asking you a point of view from maybe something related to the innovative side of the experience that you did. You can talk for example, about methodologies. She says that these experience are projects that are full round projects, and she's thanking you all and FPK and especially the girls. So we want to hear your voice, because this year there were a lot of girls and they were, yes, they were so great, and we're so happy about it. So we would like to know something about, from the point of view of the girls, about innovation of the project. How did you feel about the experience? Also the guys.
Yeah.
We don't, but first the
Gender
girls.
equality, gender equality. Yep. Matteo, would you like to start? We start from a guy.
Okay, we start from
so
a guy.
that the girls can think about it.
Okay, so I think that it was a really inspiring experience. The work we put together was really, we put all our effort into it, and we are really grateful for this opportunity, to all the tutors, and also I'm really grateful to all my peers, all my mates. So I'd really like to thank for this opportunity.
Yeah, thank you, Matteo. Thank you very much. Clara wants to add something, I guess, and Carmen as well. Or is it right? Okay.
So in terms of innovation, all of the tutors have been really supportive with all of the growth that we've done. They're up at the oddest hours because of the difference in time zone. And so having them help us and really walk us through everything has been something that I've really appreciated. In addition to that, just being able to call up any one of our teammates and ask, oh, did you understand this? Could you help me with this? Can you explain it? Was really just something that I found super unique about WebValley.
Okay.
Thank you very much.
Thank you. Carmen, do you want to add something? And also John?
Well, there's not much to add. There's not much to add. I like the format of the project with alternating lectures and scrum meeting moments where we would just meet all together and brainstorm and collect ideas and understand what we would have done in the next step of the project. And I like the fact that we put the lectures on most of them in the morning, where we couldn't all attend them in presence, and some people had to rewatch them when they were recorded, while we put these collective communicative moments in a time where they were accessible for everyone. And I think that's a point of strength of the WebValley 2020 project.
Yeah, so for innovation, I think our entire project kind of embodies innovation and specifically single cell sequencing, because I didn't realize how much knowledge you can gain from just looking at data sets and running UMaps and different types of clustering, and how we can look at different types of genes and cancer cells and T cells. So I think single cell sequencing is such an innovative tool, and I was really happy we were able to use it this summer. Also, I think innovation, so one thing that WebValley made me realize was that innovation isn't limited to just the project. You have to think about so many other things, like the customer, what your goals are, the different stakeholders. And I was really glad that WebValley provided that different and new perspective on what innovation entails.
Okay, thank you, John. We will go with the last question. It comes from our special guest, one of your lecturers, Leland McInnes, and he's first of all, he says congrats to you and to your work, and then he wants to say something more specific. He wants to say if, in your opinion, there could have been something to learn UMAP easier to use, to make UMAP easier to use, and also more useful for the tasks you use it for. Is there somebody who wants to say something?
That's a tough question, I guess.
That's a tough,
yeah.
Yes. Maybe Davide, do you want to say something?
Yes, really using the part of using UMAP more than understanding UMAP was very easy, because we just had to call a couple of functions, set a couple of parameters, and we had those powerful machines that let us really play around with the values. So we didn't encounter many difficulties in using UMAP.
Carmen wants to add. Oh, sorry. Carmen wants to add something, and also Matteo.
Well, as Davide just said, the usage part wasn't the problem, but the understanding one. And I think the only suggestion I can give is to maybe change the order of the lectures, because we first had the dimensionality reduction lecture and then the machine learning one. And I simply think that doing the machine learning lecture first would help us see it in a more clear way and build the knowledge from the ground up.
Yes, as you know, Carmen, this year it was complicated. It was our first experience, and the timetable was continuously changing. But I think that in the end, I think that we did it, and we like to have your feedbacks about it, and also I think that our guests will definitely note it. Okay.
Absolutely.
And there was also
maybe
Matteo.
Yeah, I think that the UMAP is a very interesting technique that has many different practical applications. So maybe one way to understand it better would be first make the students try it practically and for them to understand what it does, and then having the theoretical lesson to explain them why it does that thing, how it can reduce the dimensions of our data set, and why it's useful for so many applications.
Okay, so now I think that we can close the Q&A session, and we are going to call the scientific advisor of the program, Cesare Furnanello, here for you.
Yeah, bye.
Bye.
Hi, first of all, congratulations. This has been a very program, and probably some of you has met me as the oldest student in the course. That was a lot of fun, and I think I just want to say that there are elements in what you have done that are really top quality. And I will try to touch a few of the points. So I think you have proven to yourself, for instance, the capability of becoming, say, co-workers with others in scientific endeavors, and using the cloud, using data science, using all the new tools. So actually, there is something new as profession. It's not only what happening on the working from home or the COVID times. It's actually the possibility for young people that can use some spare times to get involved in research teams. So we tried very hard to have smart guys like you into our labs, and now is possible the time in which we can have people like you maybe working a few hours per week. And you should look if groups are starting to promote this opportunity. Also, as you've been working on something which is really on the edge of research, and is still very in the young field. So while clinical application sequencing are already clearly important, single-cell sequencing is still something which is really research, but you got very close. And I guess even if it was hard for you to work with a UMAP or these kind of tools, this is actually what people that with years of experience biology and computational biology are trying to achieve. So you did it in 10 days, 7 days. So that was definitely great. I think also I really appreciate. I think is a merit of the team here, but also you've been able to work with cloud computing resources within the cloud. Is a big team, relatively big team. So how you should reflect how important how different working these resources, some powerful resources, and it would be good if schools could be able to acquire these resources. I also I was in the background, but I've seen that you have been learning a lot of tricks for working together in small groups and then putting together the work. And this kind of stuff, unfortunately, is not taught at school. So it would be wonderful if in your current life as students or in future life as junior researchers, you could use this kind of ideas. So it would be good in the future if some of you is writing a blog or something that can be reused for that. But all in all, I think I'm in love with your video tutorials. That is very good, much better than everything I've seen around, and also the animated movie. So congratulations, whoever has been working on that. I would say goals have been completely achieved. Of course, you must have been struggling with staying in times, but he has been lost on the ground. So really, congratulations to you and all the team, because really something special has been constructed together. And I don't know if the format is going, the thing is going to resist on the time, but definitely is a first step in a very nice direction. So I can't say enjoy the summer because we are ready to start again in some way. But I think congratulations again. Enjoy the good work you have been doing with your friends from Italy. Ciao.
Thank you very much, Cesare. And now we're going to go back briefly to the students that will introduce as a group, and then they will talk about the tutors that they had, and then we will say goodbye to you. And thank you again for watching us. Bye.
We would like to thank the WebValley team. Displayed here are our directors, Giuseppe German and Claudia Dolci, and our scientific advisor, Cesare Forlanello. We would like to thank our tutors as well, Gabriela French, Luca Coviello, Marco Cerci, Alessandra Potrich, Rachele Villani, Elisa Guardabasso, and Beatrice Del Petri. We would like to thank all of our guest speakers listed here with their respective topics covered: Andrea Brunello, Valerio Maggio, Nicole Basule, Bruno Papa, Giacomo Baruzzo, Leyland McInes, Enrico Lavezzo, Frederica Res, and Alessia Marcolini. WebValley Reimagined included these participants displayed here from both Italy and from the US. Finally, we would like to thank the partners and sponsors listed here that helped make WebValley Reimagined possible for this year, despite all of the conditions. Thank you so much.
See you.
See you next year.
Bye-bye.
Bye.
Thank you.